Okay. A student investigates how the average speed of a trolley varies with starting height. Okay, there's our trolley. Part A. Describe how the student can determine the average speed of the trolley. 4 marks. Right. So we've got to extract 4 marks out of this question. We're looking for average speed. That's what we have to calculate. So you can start by saying that average speed is distance over time. Okay? Even if you can't think of how to start, you know that speed is distance over time, so just get that down on the paper. Okay? Now that means we need to measure the distance that the trolley is going to move and the time it takes. So to measure the distance, use a meter rule. Right? Don't use one of those little 15 centimetre plastic things like 4 or 5 times. That's naff. You want to make the measurement all in one, so use a meter rule. Okay? What else can we say? Right, that's the distance, we have to measure the time. So use either a stopwatch, obviously, okay? Or you could use a light gate for greater accuracy. Okay? What else? How else are we going to get our 4 marks? Right. You have to make sure that the start and stop points, the points where you're going to start measuring from and stop measuring, are clearly marked. So start, stop points are clearly marked and consistent. Okay? So you need to stop the stopwatch at the same point, or when the same point of the trolley passes the same point every time, consistency, and start the trolley always at the same point, and mark these points clearly. Okay? Right, we're well on our way to 4 marks. Okay? Right. And the big one. For these sort of questions, always say repeat. Okay? You always get a mark for that. You take the measurements and you work out the average speed. That you've measured the speed, you've measured the time. Sorry, you've measured the distance, you've measured the time, so you can work out the speed. You have to repeat that at least 10 times. Okay? And take the average. Right? Always mention the repetition thing. Good, and you'll definitely get 4 marks if you get all that down. Right. Okay, I'm going to have a moan for a second here. At the start, this question said, a student, right, the whole question 7. A student investigates how the average speed of a trolley varies with starting height. Okay, fine. Right, so we're going to change the height. Yeah? And that's what we've got here, starting height and average speed. Okay. But then, part A, they move in and specifically say, this is what we've just done, describe how the student can determine the average speed of the trolley. Okay? So it's not talking about height, it's talking about just how to measure the speed, as far as I can tell, for a particular height. And then in the mark scheme, they give you a mark. You can get at least 1 mark, and I haven't included this because I don't think it should be included, for saying something along the lines of the measurement of the vertical height to starting position. Okay, in other words, the height, I think that's what they mean, of the trolley. Well, if you're watching this, EdXL, can you be more consistent, please, and clear in what you want? Because part A asks for a description of how the student can determine the average speed of the trolley. So you shouldn't really be giving a mark for talking about measuring the height. If you're going to give a mark for measuring the height, then the question should have been something like, describe how the student can carry out the whole experiment. Okay. All right, moan over. Let's get on with it. B. Right, the trolley mass is 600 and 50 grams. Calculate the average kinetic energy of the trolley, which had a starting height of 0.075 meters. Right, we're over here, we're looking at the graph. So they've given us this graph of the average speed of the trolley. This is the student's results against starting height. Okay, mass of the trolley, 650 grams. Calculate the average kinetic energy of the trolley, which had starting height 0.075 meters. So, what do you have to do? Kinetic energy, right? Kinetic energy, the formula, and you need to know this, is half mv squared. Right, they've given us the mass of the trolley, so we just need the velocity. They've told us the starting height, 0.075, which is about there. Okay, so how do we get the velocity? We clearly have to go up and along to get the speed or the velocity. Right, so go up and along, and it turns out that it's 0.6 meters per second. I've drawn this by hand. I've tried to get it reasonably accurate, but your question sheet graph will be slightly different, okay? And it should turn out to be about 0.6 on your question sheet. So the speed is 0.6. So V is 0.6. If you get 0.61, 0.59, something like that, that's fine, okay? As long as you're as accurate as you can be when you go up and along. Okay, I'm going to work with 0.6. 0.6 meters per second. Right, so stick it in. Kinetic energy is half the mass. Don't forget to convert into kilograms. 650 grams is 0.65 kilograms. Okay, so half m is 0.65 v squared. Velocity is 0.6. Okay, so it's half times 0.65 times 0.6 squared. Stick it in your calculator and you get 0.117. Kinetic energy, unit of energy is joules, right? Let's round that and make a sensible choice. 2 decimal places look sensible, okay? Which is going to be 0.12 joules to 2 dp. Nice, sensible choice. Good. Okay, B part 2. Determine the gradient of the graph when the height is 0.1 meters. Right. Height 0.1 meters. So we are looking at the gradient at that point there. How do we calculate the gradient of a curved graph? You have to draw the best tangent you can at the point we're talking about. And don't just do a little one here and make a little triangle because it'll be inaccurate. Once you've drawn the tangent, make it as long as you can so it cuts the y-axis, okay, and goes up a long way on this side as well. So here we go. Tangent is going to be something like, it's not a good start. Let's get it straight. That should be a straight line. Obviously, you should use a ruler, okay, when you're doing this. So, I've drawn the tangent at the point we're talking about, taken it through the x-axis and a long way on this side as well. Okay, need to take it up to at least 1. That's a sensible choice. It's a nice, easy number to work with. Okay, so we're going to go across to there. Cuts the x-axis about there. The way I've drawn it, again, this is hand-drawn. It's going to be slightly different on your question sheet. It'll cut the y-axis somewhere slightly different. Okay, right. And I've chosen 1 there that's nice. You can calculate the rise nice and easily there. So whatever number that is might be near 0.2 on yours. Okay, again, this is hand drawn. Okay, so to calculate the gradient is rise over run. Okay, rise over run. So we've drawn our triangle. The rise is, okay, from there to here. So that's the rise, or delta y if you like. You can draw it delta y over delta x. Same thing. Rise is change in y value over corresponding change in x value. So the run, or delta x, is from here to here. Run. Okay? Now, like I said, you could have taken a point here somewhere, maybe, and only gone up to about here, and your delta y, or rise, would be there, and your corresponding run would be much smaller as well. Don't do that, because you won't get an accurate, your result won't be as accurate as it would be if you use as larger values as you can manage, like I've done here. The change in y, the rise, is as big as I could make it, and so is the change in x, okay? Use all the space you've been provided with. The larger the rise and the larger the run, the more accurate the answer will be. So, on your graph paper, question paper, read off these values that you have. In my case, it would be, the rise is going to be 1 minus, looks to be about 0.3, okay, so 0.7 over the run from 0 to 0.195, okay, something like that. Now, I don't know what that number is. Let's not worry about that too much. On the mark scheme, it says, because you guys are going to be doing it on your question paper, which again, I keep banging on about this, I've drawn this by hand, my number's going to be slightly different. They're looking for a value between 3.5 to 3.6, okay, which is, like I say, don't worry about my numbers too much. You should, apparently, if you've done it accurately, you should get an answer between 3.5 and 3.6 from your question sheet, which isn't much. They don't give you much leeway, much room for error. It's quite a small range there, slightly worrying, but good luck with getting a value in that range. But as long as you're accurate, you're sensible, you do it the way I've described, in the real thing, you'll get a correct answer within acceptable parameters. Good, okay. B part 3. Describe how the speed of the trolley varies with the changes in height made by the student between 0.04 and 0.12 meters. Okay, 0.04. Right, okay, yeah, okay, that's fine. So 0.04, let's do this in a different colour. Let's do it in pinky stuff. Right, so 0.04 is about there, okay. And at that point, the student took a reading there, okay. The corresponding y value will be slightly different on mine, again, because it's hand drawn. Anyway, he took a reading at 0.04, 0.09, which is about there. Right, he had a data point about there. And 0.12 meters, which is about here. And it's more like here, isn't it? Yeah. 0.12, which is about there. Okay, So the student has these 3 data points, these 3 starting heights, and he got whatever values of speed. Describe how the speed of the trolley varies with the changes in height made by the student between 0.04 and 0.12 meters. Okay, 2 marks. It's only 2 marks. Right. So it's this boring standard type exam question. Right. So he took a point there, there, and there. First thing to say, as he increased the starting height, okay, went from there to there in this direction, there to there, and then to there, in both cases, the average speed increased, right? It's generally in that direction, okay? So in both cases, both times, increase in height led to an increase in average speed. Okay, 1 mark. For the second mark, it's curving like this, okay? So there was a greater increase in speed when he increased from 0.04 to 0.09 than when he increased from 0.09 to 0.12. Okay, that change in speed there is greater than that change in speed there, like I say, because it's curving in that direction. So a larger increase in speed from 0.04 to 0.09 than from 0.09 to 0.12. Okay? And if you want, you can say something like it's because the average speed increases at a decreasing rate as you increase the starting height. Okay? There's a non-linear relationship between average speed and height. Let's move on. Excuse me. Okay. Devise an experiment, part C. Devise an experiment that would allow the student to investigate the effect of different surfaces on the speed of the trolley. Okay. So now, we're not interested in how the speed varies with height. We're interested in how the speed varies with different surfaces of the ramp. Okay, so 3 marks. Let's change colour. Right, how are we going to get 3 marks out of this? Start with the things you're going to keep constant, okay? So if we're interested in different types of surface, you have to keep the height constant, okay? You have to keep, I mean, these might seem obvious, like the length, it's the same ramp, okay? The length's going to be the same, but often in exams, it's exam technique I'm talking about, you say the obvious, you get marks, okay? Never be shy of writing the obvious. So we're going to keep height constant, we're going to keep length of the ramp constant, we're going to keep the angle, again, it seems obvious, like the slope angle, constant. Anything else? The start and the end points. Okay? All of these we're going to keep constant. We're going to vary the type of surface and keep all these things constant. Okay? What else? 3 marks. So we've got at least 1 mark already. Right, use as many different surfaces as possible. Okay? use different surfaces. Again, it seems obvious. We have to vary the surfaces. That's the whole idea of the experiment. You could have, what could we have? You have a plastic one, maybe, a wood one, a damp one, a metal one, and a polished one. Okay, that's 5 different types of surface. What else? I'm running out of space here. Okay. Right, so devise an experiment. It asked us, early on in this question, describe how the student can determine the average speed. So you can repeat yourself a little bit here to get the rest of the marks. That was a 4-mark question, part 7a. Describe how you can calculate the average speed, or describe the experiment. So you try and summarise that for the rest of this. So again, say the obvious, calculate the average speed for each surface. Okay, and again, like in part A, just the things that you need to do the experiment. Speed is distance over time. Like I kept banging on about, repeat and take the average. Okay? If you want to say things like use a meter rule, stopwatch, all those sort of things. Light gate. Anyway, it's a 3-mark question. That will get you your 3 marks. Oh, that was quite a long question. Well done. Right, that's the lot. So I hope that's helped. A fairly dry, boring, painful style of exam question, but there's been a lot in this question that uses exam technique. It's the same sort of things, the same type of answers you have to come up with again and again in exams, and this question is a good example of that.